Um, Good morning, everyone. Thank you very much for joining today's Brunel Cup of Science session. We have the pleasure to discuss with Professor Abdul Sadka, Director of the Institute of Digital Futures today. Thank you very much, Abdul, for your time and for being with us today and also for playing the game.
No, thanks, Michael, for giving me the opportunity. Thanks for having me.
And I hope you all have your essential accessory today, your cup of science right here. I always start by asking you, how are you today? And I hope you're doing very well.
I'm looking forward to a better weather, that's for sure. Really feeling more summery now, but yeah, not too bad at all.
That brings me to Abdul's country of origin. Here you can see a beautiful photo of Abdul for the launch of the Institute of Digital Futures back in January. But the link with the good weather is that Abdul grew up in Lebanon, and he went to the university there studying engineering at the Beirut American University, and he's done a master then in Turkey in engineering. And actually nothing predestined him to be a guru of image processing of multimedia, because his final year project was then on particle coagulation, so nothing to do with image really. Then he moved to the UK and he went to the University of Surrey, started as a research assistant, then a PhD, and he also got his first job there at the University of Surrey. He climbed the ladder, lecturer, senior lecturer, up to reader, and then joined the University of Brunel. He really has been pivotal in coming up with international standards for video encoding, especially on the topics of error resilience. Then went on to look at context-based search. When you Google a video, when you Google a keyword, and when you want to find out what's the content of a video, well, that we have to thank Abdul for this. And then lately, he's also working a lot on holograms, holographic images. Now, what you see here from this image, this is not how you usually see Abdul in the lab. And Institute of Digital Futures, I believe that in his early days, Abdul was a fan of Star Trek, because I have a video here, and look how Abdul suddenly appears in the future here.
Hello.
Boom. And I hope you had the sound, but just before Abdul appears, you can see this artifact. I think it's a aliasing artifact, this multicolor, and that really reminds me of how characters were appearing in Star Trek. So I don't know, were you a fan of Star Trek?
No, not really, not at all.
Not really. It's okay. So I lost it. I thought this was really really interesting for this video about the future. And Star Trek, of course, we all know it's about the future. Now, when we speak to Abdul on a normal day, we don't see him in this very nice setting, but we actually see him like this in his lab. So he's proudly standing in his room, and usually the background that he has on Teams is a green background, but he actually just told me that he didn't manage to have to set up the background on his Zoom account, and I thought this was a bit odd for an image guru as Abdul. All right, Abdul can very proudly stand in his lab because he authored, he wrote more than 200 papers, and he also has a very highly regarded book published in 2002. About video compressing and communication, where he really outlines his error resilience theories. And that's a very important book for him, and he believes this is one of his greatest achievements during his career. Now, what you might not know is that one of his hobbies is actually a licensed radio amateur. He doesn't practice this a lot lately. He's very busy being also the director of the institute. And Abdul, I hope this is not your password, but his pseudo is Moleb, so Mike Zero Lima Echo Bravo. So if this is your password, please change it immediately. And this is actually linked to what you're doing now, I believe. You're very good at Morse code, and when you passed your exam, you actually managed to decode. Was it decoding or writing 32 words per minute?
Yeah, it's both listening and transmitting, really. So the
I suppose listening can go faster.
Indeed, yes. Yeah, this is just keying 32 words per minute. So this is on average about 150 characters.
So you can see how his hobby can come out of his professional life, where he really has a flavor for signal processing and decoding images, and of course Morse code. There is some coding in there. Now that actually brings me to, well, somehow being upset a little bit, because of people like Abdul, we have all those different file formats when we look at videos. I mean, it all starts, well, AVI, MOV, and MPG, and now we have MPEG 4. And yes, so he's been contributing. And I have a question, the first question for Abdul. Do you actually know what MPEG stands for?
Oh yeah, Motion Picture Experts Group.
Expert group. So that's very important, because he actually was part of a European group where you decided on what were the standards for video compressing, video encoding, and how videos could be shared. My first question for you is that you seem to have a passion for signal processing, but not any particular signal, images rather than sound or text. And so the question for you is, what do you think about an image being worth, and that a picture is worth 1,000 words? Why do you have this passion for images as compared to other signals, sound, for example?
Yeah, thanks, Marco, first of all, for organizing that along with Dom. Thanks for giving me the opportunity to speak out to the public, to my colleagues, and the outer audience as well. When it comes to your question, I think it did come by coincidence rather than by choice. As you rightly pointed out, it wasn't really planned that I am in that field of specialism. When I first did my postgraduate studies, I was more focused on networking at that side. But then it was by sheer coincidence that my PhD supervisor tried to convince me that multimedia is going to be the way forward. And he gave me the text of a successful research bid that they had at the time. It was very fresh. He said, why don't you take it, read it over the weekend, come back and discuss it with me on Monday? So I took it away and went through the proposal. It was really, at that time, it was very much detailed to me. I wasn't familiar with the area, but I thought, why not try to accommodate more than one modality in our signal processing work? Signal on its own, when it looks like a waveform, not carrying intelligence underneath, it looks very abstract. But when you know what type of information or modality it represents, it becomes easier perceivable. So I thought, because it's visual, linked to our human visual system, it's something you could perceive, you could identify and recognize by just looking on it. I thought this is good to to work on and research into.
And this was actually also the right time where people were moving from analog to digital. So you talked about this being random, and also you were lucky that you were there at the right time, at the right place.
Yes, I agree. Yeah, it was in early 1990s when I did my master's, and then I started a PhD in mid 1990s. It was at that time the first image compression standards emerged, which was JPEG, that we're all familiar with. So knowing that images were compressible at the time was something really new and very, very innovative. Then we thought, how about then animated images? How about videos? Particularly at that time from a storage perspective, communication was not that proliferate at that time. We did not really think too much about compressing images for transmission purposes. It was purely for storage. Mm-hmm. So I thought, yeah, it could be quite useful if we could compress not just still images, but also animated images, video sequences. So this is how it came about. And then, of course, towards the latter end of that decade, end of 1990, people started talking more openly about 2G, 2.5G, and then 3G, so essentially transmitting multimedia information. It became vital that information would be compressed prior to transmission purposes. So then we thought about compression for video sequences. I came at the right time because the baseline was not there. You know, all these video compression standards you showed in your slides, Marco, MPEG 1 and then MPEG 2 and then MPEG 3 audio and then MPEG 4. These are only releases of the same baseline, advancements or developments or improvements to the baseline, which was at that time H261. And when I joined in my PhD, H261 was not a standard at the time. It was being developed as an international standard. So I joined in the area at the right time because I basically managed to witness and contribute to the development of these standards from the baseline onwards.
And I have a slide for you now, and this is to comment on error resilience. And you know, when the big brains of image processing were somehow meeting in these expert groups, obviously compressing an image comes with error, I suppose, right?
Yes.
And how did you get inspired to come up with your error resilience algorithms? And here I have a question, but to illustrate my question, I have this slide, which is a video. Before showing it to you, you'll see dots on the screen, and the dots are going to move. And I'll ask you to tell me what you see. So you see someone walking. Now this is, Abdul, someone jumping, right? This is climbing a few stairs. Sitting. Now here, I wasn't really sure what that one was doing. And right, I'm using this to illustrate my question. Our brain, and I always like to have this biology-inspired engineering or modeling. Somehow nature invented it all before ourselves. And it looks like our brain is very much capable of filling in the gaps when we look at an image. If the image is incomplete, then obviously the retina and the first processing level in the brain receives an image that is not complete. But then the brain, through internal processing, can fill in the gaps. And that's what we see here in those images. These are just dots moving. Yet we perceive biological motion. We perceive that is actually a human being, a human being moving. So have you actually invited any perhaps neuroscientists or have you been inspired by what nature does to come up with your error resilience processing?
Yeah, what you actually just showed, Marco, is done in the context of gait analysis, gait as in G-A-I-T analysis. So this is a technology that is called motion capture. So it's basically consists of putting markers, identifiable markers on a human body, and then have multiple camera system that track the location of these markers on the human body and generate motion information. So motion tracking is done particularly for gait analysis of various patients or groups of patients, because once you've analyzed their posture and their gait, you understand whether there is any misbalance in the actual motion, or it's done purely for monitoring purposes. You've got people who are clung to their home, their domicile, and you want to track their health conditions through analyzing the motion data captured, and so on. So it's all done with human medical conditions in perspective, as it were. However, it's not the only application domain why human tracking is done. It's done sometimes for surveillance purposes. So you've got multiple humans having access to a public area, and you need to detect any abnormal movements. So you track human movements and generate inferences from that to detect possible emergency scenarios, as it were. So it has various application domains, one of which, of course, is the medical field.
Right. But about this error resilience and error detection, the brain knows where the dot is going to be next, because we have this model of walking, gait, like you mentioned. And I wonder whether, is this what you apply to your image processing, where if you have a yellow pixel, it is very likely, in other words, your software, your algorithm predicts that the neighboring pixels are going to be yellow, or a degree of yellow. So is this what is encoded in your JPEG, and then in your MPEG, the neighboring pixels are actually, well, what is the likelihood of the neighboring pixel to be of a given property, of a given color, given position, given speed? Is this what we are talking about here for the naive in the field?
For the lay audience, I would say errors in visual media can be generated by two main factors. One is compression. When you compress information, you make it more liable to errors eventually. But the other type of errors, which is what I've been looking at more rigorously, if you like, over my research career, is the error that is generated by networks, that is putting information on network environments like mobile, for instance. Because once information travels in networks, it gets interfered, it gets intercepted. There are other many factors which impact the quality of information once it is put in a network environment. One of which, for instance, is propagation, delays, shadowing effect, multipath, fading. There are several factors that people in communication know that could impair the quality of information once it gets communicated over the network environment.
And
so
how can you restore it back to the original?
Okay, so this is the key thing. I mean, error resilience. This is why error resilience as a field has emerged in video communications, because compression on its own is not good enough. Any compression standard, no matter how efficient it is, would fail, even in the occurrence of a single bit error. So just one bit being an error, 1, 0, or 0 received as 1, could have a dramatic effect on the perceptual quality of video. So error resilience has emerged in the context of video communications in order to mitigate the effects of transmission errors and retrieve part of the quality. And how is it done? There's a whole range of techniques that we have developed over the years, over the last 20, 25 years, to look at that. I mean, one range of techniques, if you like, is looking at neighboring information, that is information that has been correctly received, and try to replace the missing information or the corrupted information by the correctly received one. That's one aspect of it. This is called robustness, error robustness techniques. The error resilience techniques look at preempting the occurrence of an error at the encoder stage, before the information even travels onto the network. So you either send duplicates of important data, that is, you send it twice. So if the first version gets corrupted, you got always an error-free version coming after. Or you change the transmission order. So rather than sending data in sequence within the image, one pixel after another, or one block after another, you send it randomly. So if in case the error occurs, then you spread the error both spatially and temporally. So you mitigate the perceptual, the visual effect of error impairments, and so on. So there are several techniques that look at error resilience, but the main thing is that error resilience occurs at encoder stage. Error robustness is a decoder-based error concealment technique.
And now you're moving from this 2D type of video, so a sequence of images, making a video, into more 3D images. You know, your holographic studio that you have at Brunel. So of course, this is going to require even more sophisticated error resilience algorithms, I suppose, if one wants to, you know, transmit a hologram from point A to point B somewhere in the world. So, and of course that goes in parallel with our communication means, sort of 5G being there, because we need a much larger bandwidth to transfer this. So how did you move from 2D to 3D? Why did you go into holographic video now?
Okay, so it was part of the chronological development of events, of technology in this field. When I first started in mid-90s, 3D did not exist at the time. Holography was just the type of puppetry type of scenarios, visual experiences that people would know, you know, with animated figures, so light reflections essentially, but it wasn't really a digital representation modality of information. No one knew how visual information could be represented using 3D modalities and so on. But then 10 years down the line, maybe in 2000, 2005, HD TV emerged, the concept of having high definition TV in 3D. So 3D TV sets became then commercially viable as a possible future direction of technology. So people then started thinking about how is it possible that information, visual information, could be represented in 3 dimensions. So it all started with not holoscopic, but we started with stereoscopic modalities. So when you have 2 views, one representing the right eye, the other one for the left eye, and for representing a certain scene in 3D, you need 2 views. So at that time, it was very, very premature technology, because it very much mimics how our human visual system operates. You know, we capture 2 images to anything that we see in our physical space, and then the brain would be able to compose the depth perception from the 2 views that you have captured with your human visual system. But this is not good enough, because it has some limitations. 40-45 minutes down the line from watching a certain movie, stereoscopic movie, you develop an eye fatigue and brain fatigue, talking about the IMAX cinema type of experience. Mm-hmm. So it has limitations, because your brain is constantly working on composing depth, and because of that, you've got eye fatigue, and you've got as well a headache that may develop after half an hour into.
And what you do in the lab doesn't give you fatigue.
No, it doesn't, because I mean, this is the evolution of things. The second stage was how could you circumvent this eye fatigue and eye and headache. Well, we then talked about multi-view systems. Rather than having just 2 views, you have 8 or 9 views, and there's no need then for wearing glasses. So your brain doesn't necessarily have to capture 2 views and compose depth by wearing shutters, glasses. Without any glasses, you would be able to capture 2 of these 8 or 9 views at any instant of time and be able to perceive depth. But again, the system has limitations, because if you move within a certain viewing field, you lose 3D. There are some barriers within the viewing field. Okay, if you step a little bit to the right or a little bit to the left, 3D is lost completely. Then came our technology, which is holoscopic. It's provided solutions to both stereoscopic and autostereoscopic, no glasses needed, and there's no discontinuity within the viewing field. So even if you move right and left within the viewing region, then you wouldn't lose depth at all.
But does that mean that at the source you need a lot of sensors to capture those images? So how many?
Yeah, you need a single sensor still. I mean, that's the good thing about the technology, is that you use just a single camera sensor. Any camera off the shelf, 2D DSLR camera, can be converted into a holoscopic camera using a multi-lens array. Multi-lens array that we have engineered. You put it right in front of the sensor, the camera sensor, and that would enable you to capture not just a single image, but millions of tiny images. Each one of these micro lenses will produce an image for you. And then the collection of all these images will make up the holoscopic image captured. And then when you want to display it, you go through the reverse process. So you take all these tiny images, put them through the same lenticular sheet produced for acquisition, and display the image as a light field. So it wouldn't be projected as normal video projection systems work, but it will be actually it will be a reproduction, a light field reproduction of the object captured, not an optical illusion of depth, but an actual reflection of the depth of that image.
Yeah, that is really fascinating. And do you foresee that, you know, instead of using Zoom or Teams and having a 2D image of ourselves here, we are going to be able to soon use those holographic kits at home, and we are going to be able to see ourselves in 3D?
Yeah, that's a 6G development. I mean, the technology now is focusing on this particular application, holoscopic communications, within the context of 6G as it is currently being developed. So 10 years down the line, Marco, when 6G is expected to emerge as the next generation of mobile wireless telecommunications in 2030, as anticipated, one of the killer applications of 6G will be holoscopic communications, in the sense that when you set up a communication session with a certain participant somewhere else in the world, what you're essentially interacting with is their holograph, who will be physically immersed with you in the same room, and you will be able to interact with this 3D reproduction of that communication participant as if they were physically present in the same room as you are.
Yeah, this would be amazing. Also bringing, you know, on the topic of links between digital futures and health. How imagine a clinician being able to see a patient in 3 dimensions to look at diagnostics and perhaps to you know, have some therapy being done to the patient, because obviously in parallel to these visual displays, we'll probably have haptic features as well, where we can remotely touch patients as well through robotics that provide those sensory inputs. So what do you think, obviously now with the pandemic, there is people have a very heightened awareness of research in health, and the Institute of Digital Futures has a lot of applications for health. So how do you see that going in the future, and how can the Institute promote those collaborations?
Sure. I think the approach we're taking is challenge-based. So we, rather than addressing fields in a disciplinary context, say, signal processing or clinical sciences in their own merits. We address the challenge that emerge in societies. What are the global challenges that we are faced up with now? Whether it is in health, in climate, in economics, in education, and so on. And then we try to produce solutions that address these challenges naturally from a multi or cross-disciplinary perspective. So this is how digital health emerged. There are some challenges. You've mentioned one of them, which is telemedicine or remote health, that came on the surface, which require the integration and maybe agglomeration of several disciplinary expertise coming together to address and provide solutions to the challenge. Digital health is one of them. It's not the only one. Manufacturing, smart manufacturing is again a key area where you have integration or maybe synergization of disciplines coming together in order to resolve the problems of one particular challenge area.
So this challenge-led way of working is somehow an answer to, you know, the question I asked you 2 weeks ago when we met. You know, do you really think that the future is all about digital? When, you know, on the opposite side of the spectrum, you have a lot of people saying, well, we should go back to the countryside, having a farm, grow our own carrots, and perhaps, you know, use a candlelit, you know, to read a proper book rather than using I don't know, a tablet. So, and you said, and I'm quoting you, it is too late to go back, but in a way we have to address those issues that society is facing now, and one way to address those issues, or perhaps the only way to address those issues, is through digital.
Yeah, I think digital helps streamlining processes, Marco. Digital is not the only solution, but it is one solution that helps you not just provide solutions, but provide streamlining to the solutions provided. So I think people would still be able to generate solutions to emerging challenges, emerging problems without the assistance of the digital technologies. However, with digital, they will be able to make them more efficient. So basically resources could be shifted to somewhere else within a particular business or a particular sector with the use of digital technologies. So we see now very recently digitalization of processes within the manufacturing industry. I mean, NHS has set up a new group called NHSX that looks at digitalization of the NHS processes and procedures to make them more streamlined, more efficient, and so on. So digital technologies aren't the only response, but are a very important response to providing solutions to emerging challenges because of the effectiveness that digital technology would create in providing solutions.
And so we have a question here from Akram, and that's, you can use the chat here, everyone, to interact with us if you want to. So how do you embed intelligence and value into digital when it could disconnect with the human? So I think,
yeah, I think that's a good question. Akram is full of those good questions. I think, you know, the more human technology resembles, the better. What I mean is that the closer representation that digital technologies could provide to humans in terms of their abilities to sense, and here I'm not just talking about haptic sensing, I'm talking about all other senses as well, smell, taste, hear, and so on. The closer the technology is able to reproduce humans in the virtual world, the better the technology, the closer it is to our human operations and processes. And I think that's the challenge. Hence, I talked earlier about 6G, the killer application being, how can you reproduce humans using holograms with full sensing capabilities? So you are able not just to talk or see your participant, but you're able to interact with them, smell them hear them, maybe handshake your participants and interact with them physically and so on. So it opens up a wide range of areas, bringing us closer through technology to the actual human perspective, human representation. And
right,
so
it goes back to the being inspired by biology. So doing
yes.
those type of modeling, and of course that comes, well, this is what you follow with your video processing towards holographic, which becomes a much more natural way of perceiving our environment in 3D.
Yeah. So what I wanted to say is that it's not just about cameras. The future is not going to be, I mean, in response to Akram's question, it wouldn't be just cameras and microphones and speakers on the other end, but it would be other types of sensors, the modalities of which need to be integrated along with the YUV or the RGB or the type of visual sensors we use in cameras today, along with the audible type of signals, mixing together all these modalities in order to reproduce, if you like, the human subjects that you are communicating with, and hence technology would be more able to represent humans and their actions and their behavior and their interactions and so on.
So, of course, there's a lot of work to be done yet. We are mostly talking about visual inputs here, that the sense of vision, but we have haptics, and with haptics in virtual reality, we are very far from achieving what we can feel in the real world for sure. And then, yes, you mentioned all those, how can we bring emotions through a computer screen? And we actually noticed now that a telephone call, so just sound, is not good enough when we interact with our colleagues, because we are missing body language, and there is a lot of communication going through a video. So we noticed that other channels are important, and now we have those two channels, sound and image, but there's much more as well, which happens when we meet physically in a room somewhere, in an office at Brunel University. So yes, there is a lot of work.
It makes it more human, or human-like, in response to Akram's question. I think when you incorporate other types of modalities that we humans are used to seeing or perceiving, smell, taste, touch, and so on, then it makes the communication, it makes it more human like.
Yeah, exactly. So questions now about advice for early career researchers in the field of engineering, in your field. And I want to start with your example. You were a PhD student at the University of Surrey, and sometimes supervisors say, well, it's actually very good if you were doing a postdoc somewhere else, because it's very difficult to find a lectureship position within the same university where you've done your PhD. You somehow have to show how good you are abroad or somewhere else, and perhaps then you can come back. And in a way, this is not what happened with you. You actually applied. So there was a lectureship available at the University of Surrey, and your supervisor told you, well, there is a 0.001% chance that you'll get it, but still do it. So is that an advice for ECRs?
Having a vision, I think, ahead of time where you want to be upon completing your studies does help. It's not a precondition for your success to have a vision ahead of time, but I think it does help with you becoming more able to shape, I think, your career pathway with a clarity. In my case, I knew that I had the potential and maybe the desire to pursue postgraduate studies, but I didn't know where I should end up, what sector. Is it in industry? Is it in the higher education sector? I had no clue. Not because I didn't aspire to becoming a successful professional, but because there was some lack of information, perhaps, as to what each sector entails, what are the challenges, what are the required skills that I should develop in order to fit one particular area. So I think having this clarity ahead of time does help, but it's not, I don't see it as a prerogative condition that must be fulfilled for someone to be successful later on in their career. So my advice, I think, to anyone who would like to pursue PhD studies, or they are going through their PhD course now for the future, is perhaps to look, to have an outward look, not an inward look just. What I mean by that is that, you know, the world of technology is quite broad, and there are huge players out there, some of which are in university environments, that is higher education sector. Others are in global, multinational acorns type of companies, of businesses. Others are small businesses, and all of them are players in that huge field. So in order for you to stand there in this rather very competitive world and make a difference and contribute to the advance of the field, as it were, having a clarity is one thing that is very useful, but looking out to this world in the sense that know what it takes to be there and to achieve success in this very competitive field is very helpful. So I've seen many early career researchers complete their PhD studies, and if they are successful enough to get lectureships, they'll be so much focused on the interior atmosphere or environments they find themselves in, their departments or their groups or their divisions, and in some cases universities, but they ignore what happens outside. So 10 years, 15 years down the line, this ECR who becomes Dr. X or Dr. Y is not known to the field. Who is it, Dr. X and Dr. Y? What contributions have they made, apart from their papers, which get cited here and there? But what is it that they've added to the field? What applications and services they've developed which have benefited society? No one knows about. So my advice to them would be to have this outward-looking profile. Look what's happening else, and make a profile for yourself in the outer world, and not be too much ghettoed, if you like, or enclaved within your office space or your departmental space.
And is that, you think, so to get funding now, you think this is how candidates are being ranked, not only judging them on publications, papers, citations, but also how well they are connected with industry, so yes, externally looking.
Yeah. Not to say that colleagues who choose to be inward looking only would not be successful in attracting research income. It does happen. There are several success stories for colleagues and academics who've chosen, for a hook or a crook, to be very much inward looking, but still have achieved success in attracting income and generating good output. But what I'm saying is that if you want your contributions to the field to be recognized outside your community, scientific community, outside the context of journals and proceedings and so on, you need to engage with the user communities. You need to engage with industry, businesses. You need to engage with the public, so that they know that whatever you're doing in your lab throughout your research does have an impact, socioeconomic impact. You're providing solutions to their problems and so on. And this can only be done through interaction with the global communities, whether it's the business sector or the public audience.
So this is very interesting. This is a theme that's been going across all 3 weeks so far for the Brunel Festival, where, you know, every director has said, you know, we have to be outward, you know, looking outside of the field, being multidisciplinary, so not work within, you know, in silos, but looking horizontally. And that's why I think the institute such as yours is very important, to connect researchers with the, you know, what's outside the university. And how do you facilitate this as a director of the institute?
I think the approach of having challenge focused is inherently a facilitating platform for bringing researchers from across disciplines, because when you address a challenge which requires putting together researchers from various disciplines, then you're effectively giving them the incentive to come together, join the same team, and work on finding solutions to this challenge. I think this challenge-based approach is key to genuinely come up with multidisciplinary work, and not just for artificial purposes, because we want to do multidisciplinary work. It becomes genuine, and really it becomes authentic, if you like, or genuine when you address research based on the challenges that you face up with at local, at regional, national, and international levels.
Great. So multidisciplinarity is a big keyword here, and maybe another piece of advice for the ECR who wants to take on some leadership role within the university, because being a leader means that you have to being mentor, say something about a topic that you might not know so well as your area of expertise. I'm taking you as an example. You are an expert in multimedia image processing, yet in the institute there's machine learning, artificial intelligence, mathematicians. So that must be a daunting task somehow to be the overarching person above all those researchers. How do you approach this?
Okay, to be successful, we shouldn't shy away from learning new stuff every day. I mean, this is what I do, being the director of the institute, but even if in my previous roles, you engage with colleagues who are at the forefront of their own discipline every day. You have to learn new things from them when you engage with them on a daily basis, and you shouldn't take that down upon yourself as a source of disgrace. Just the opposite. I learn from it. I become more aware, more respectful to their achievements. So that's one aspect. Another aspect is that leadership roles require a lot of human engagement. And when you talk about human engagement, we have to think about interpersonal skills. So this is one thing that a professional who aspires to becoming a leader has to develop. How you do interact with people who are not necessarily similar to you. We share perhaps the same values, but we come from different backgrounds, different mentalities, sometimes different cultures, as it happens in higher education sector as a whole these days. So managing the human interactions with us on a daily basis, with all the challenges that it brings with it to you, is an important feature of the success of a leader, whether it is in the academic sector or really other sectors as well. So to be successful as an academic leader, you have to come to terms with the fact that you are learning on a constant basis, engaging with colleagues across the board. Secondly, you have to be able to interact with people in an effective manner, respectful manner perhaps, no matter what differences there are between you and them. You have to come to terms with the fact that it is very diverse. The sector that we work in is very diverse, very multi-cultured, multinational, if you like, and so on. And this would only be possible when you consider that as an element of enrichment rather than an element of that has a restrictive nature. So this is the way I deal with it, and this is the way I've developed myself.
Learning every day, and
yes.
Communication skills being here very important.
Yes.
This is great. So thank you very much, Abdul, for being interviewed today. I really enjoyed this conversation.
Same here.
And I actually look forward to the future of the Institute of Digital Futures.
Thanks very much. Thanks very much. Yeah. Same here.
Thank you very much for the audience as well, and for the comments in the chat.
Thanks for giving me the opportunity. I think without the Cup of Science, Brunel Cup of Science, I wouldn't have had the chance to speak about the topics that you've managed to to extract, to take out for me, Marco, and you've done it brilliantly well. So that's credits to you. And thanks, of course, to all the colleagues, the participants here, and on social media outlets as well.
Thank you, Abdul. And I do think that discussing around a cup of science brings this these other senses that sound and video can't sometimes convey. And hopefully 6G will allow us to share more of those
senses, yeah.
Cup of teas or cup of coffee.
A good note to close the session on. Well done.
Right. Thank you very much. Goodbye, everyone. Have a good day.
Thank you.